Hi everybody, it's Mrs. Mancuso. Today I wanted to do some review on redox reactions. So redox reactions are reduction. So reduction means, well, I like to say the rig is going down. So reduction is gaining electrons and the oxidation number goes down. And oxidation, if you have an oxidation reaction, the oil goes up. So the rig goes down into the earth and the oil comes up. That's a nice saying to remember it. It stands for reduction is gaining electrons and the oxidation number goes down. Oxidation is losing electrons. So if you lose a negative, your oxidation number or your charge will go up. So here's a reaction. Mg plus CuCl2 makes Cu plus MgCl2. And now I know every single replacement reaction is a redox reaction, and now I'm going to show you why. The first thing you have to do is put the oxidation states on every number. So magnesium is an atom all by itself, so it has an oxidation state of 0. This 2 came from copper, so copper is a +2 and Cl is a -1. So I just crisscrossed in reverse so I can grab my reference table and look up Cl and see that it's a -1, so this is a 2. Copper is an atom all by itself, so that's a 0. Mg is a +2 and Cl is a -1. So now I want to write my half reactions. Something has gone up and something has gone down. So that's how I know that this is a redox reaction. The one that is oxidizing, remember oxidation is losing and the number goes up. So that would be Mg. So I write it as it appears before the arrow. Just Mg becomes Mg plus 2, and then I figure out how many electrons it's lost. To go from a 0 to a +2 tells me it's changed by 2 electrons. So one atom, a change of 2 electrons, that's 2. All right, reduction. My rig is going down. So copper went from a +2 to a 0. So Cu plus 2, plus I have to add the electrons before the arrow, becomes Cu. So it changed by 2, so that's 2 electrons. So those are my half reactions. The last thing I want to talk about is, there's 2 things I want to talk about. The first is agents, and agents cause the change. So if I talk about my reducing agent, what caused reduction? Magnesium. Whatever is oxidized caused the reduction. So that's Mg. And my oxidizing agent is what caused oxidation. So what made this magnesium oxidize? Cu plus 2. So I have to choose reactants. I can't choose products because agents cause something, so they have to be there in the beginning. And the last thing I want to talk about is, would this reaction be spontaneous or not? So these are both metals, so I can use table J. So go to table J. Metals are left side losers, so they want to oxidize. So I want the metal that's being oxidized to be higher on table J than the metal being reduced. So Mg is oxidized, Cu is reduced, so I'm expecting Mg to be higher than Cu on table J. There's Mg, here's Cu. It is higher. So this, yes, it would be a spontaneous reaction. All right, and then the last thing that I want to do, I'm thinking of one more thing, and that's balancing and writing a balanced skeleton reaction. So let's come up with a reaction that, that we need to balance first. So let's say we have Fe plus NaCl. That gave us FeCl3 and Na. So if I have 3 chlorines here, that means I'm going to need 3 NaCls, and that means I'm going to need 3 NAs. So now I'm balanced. And this is a 0, this is a +1 and a -1. This is a +3 because I crisscrossed that back up. This is a -1 and this is a 0. So my oxidation reaction is Fe becomes Fe plus 3 plus 3 electrons. And then my reduction, Na went down. So I write 3 NAs at plus 1 plus electrons becomes 3 Na. Now the Na is only changing by 1, but I have 3 atoms. So 3 times 1, that's 3 electrons that would have to be gained. The number of electrons lost is always equal to the number of electrons gained. And now my balanced skeletal reaction is putting these together. So Fe plus 3 Na plus 1s becomes Fe plus 3 NAs. And if you want to just check and make sure that this is all balanced, you go like this. I've got 1 Fe here and 1 Fe here. That's perfect. 3 NAs and 3 NAs. So my atoms are balanced. And now my charges. This is a 0 and this is 3 plus 1s. So overall on this side I have a plus 3. And on this side, this is a 0 and I have a plus 3. So I have plus 3 on this side. Those charges and atoms have to be equal to show conservation of mass and charge. All right, thanks for joining me.